Okay, so I need to find a sum in number 22 of 13.2, which is the sum from 1 to 50 of 3 times the index.
Find the first one, the last one, and we got to multiply by 2. Divide one.
Think about that a little bit. So I think that's probably a good idea. So find the first one, right? Like 3 plus,
The last one, we plug in 50.
no, wait. So one, you should make sure that formula applies. So this is 3 plus 6 plus 9 plus da 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 up to 50,
Or
right?
50 spaces?
So wait, up to 50?
So it should be 150.
There's 50 of these, right? But the last one should be 150. So there should be plus 147 plus 150, right? Okay, so then you could kind of mimic this formula a little bit. You could note that the first one and the last one add together to 153. And 6 and 147, right, the inside by 1, also add up to 153. And then how many pairs are there?
25.
There are 25 pairs.
Oh, got it.
So this is 25 pairs, and they each add up to 153. Yeah, so if you want to use the other formula, right, like if you want to just do n times n plus 1 all over 2, right, then you need to be careful that this formula goes exactly with the sum of I from I is 1 to n. And this is not quite the same thing. There's a factor of 3 in there. You guys see that?
N3 or N2
So in this one,
or no, N's 1 or 3, right?
so in this one,
Sorry, that makes sense.
n is 50.
Oh, okay.
This is your 50 over 2 here.
'Cause there's 50.
And then
inputs.
this thing's playing the role of n times n plus 1, but it's really 3 times n plus 1. So this is 50 over 2, right, the pairs. And then the sum, which is 3 times the first one and the last one. You guys all see that? So a thing you could have done is you could have said, oh, hey, the I doesn't depend, or the 3 there doesn't depend on I, and it's just multiplied, right? So I could do 3 times the sum from I is 1 to 50 of I. And then you could use the formula. You guys see that? I didn't tell you you could factor constants out like that. Why can you factor constants out like that?
Because it's a polynomial.
Yeah, really kind of because this thing's sort of a polynomial, right? It's just a bunch of terms added together. They've all got a 3 in them. You can factor a 3 out of all of that junk. You guys see that? What's that?
If the top part wasn't 50, say it was, infinity, could you still factor out a thing?
You can still try, but this thing won't make any sense if it goes from 1 to infinity, right?
Yeah.
And so you're writing you're sort of writing this statement. You would be writing infinity equals 3 times infinity,
Is that true?
which is not particularly wrong, but is, yeah, a little bit funny.
That's why I yell at people when they try to say infinity's a number. It
Yeah.
doesn't behave like a number.
Yeah, that's a fair point. We really restrict it out of the real number system because the algebra things that we like to do don't work with it. Cool. Questions, things?
And wait, N is 50 because there's 50 terms, right? Inside.
Yeah, n is 50 purely by pattern matching, right?
Right. Okay.
I'm summing 50 things. Cool. Please note that this thing has to start at 1, too. If it starts at 17, you have a different thing. If it started at 17, I'd play this kind of funny game where I do,
Subtract the terms.
yeah. So I do, like, say we're summing from I is 1 to 50, or I is 17 to 50 of i's, right? I would say, hey, that's the sum from I is 1 to 50 of i's minus the sum from I is 1 to 16 of i's. And then I can use my formula on each of these and just subtract the results. Let's go with that.
Mhm.